before, we're going to start off by kind of going backwards from something that we've done before. Okay. Before, we've actually been given a polynomial function and asked to find its zeros or its x-intercepts. Okay. Let me just show you what I'm talking about. If we were given a function, let's just say this function and asked to find the zeros of it or the x-intercepts of this function, we could have, since it was x squared, gone to our quad program and put in the a, b, and c to get the solutions, or we could have put this in factored form. If I factored this, in order to get x squared, I would need x and x. The factors of 15 that add to 8, let's see, to multiply to get 15 is 15 times 1 or 5 times 3. So to add to 8, I would choose positive 5 and positive 3. So sometimes we were given the polynomial all the way written out and asked to find the zeros. Sometimes they already had it factored for us and asked us to find the zeros, which is good because in order to go from the factors to the zeros, all we had to do was set the factors equal to 0 and solve them for x to find the x-intercepts. So on this one, to get rid of plus 5, I would have to subtract 5, which would leave me with x equals negative 5. And on this one, to get rid of that plus 3, I have to subtract 3. And I'm going to be left with x equals negative 3. So today, what we're going to be given is these zeros, and it's going to ask us what polynomial function, which is this, would these zeros have come from? So we're going to kind of work backwards. So think about this. If the 0 is negative 5, what factor did this come from? It came from that x plus 5 factor. If negative 3 was the 0, what factor did it come from? It came from this x plus 3 factor. So we're going to start off by going from here, turn it into the factor, which pretty much just means if your 0 is negative 5, then your factor is x plus 5. It's just the opposite sign. Now to get from this step to list out this polynomial factor, how do I get from here to here? Well, I FOIL, right? X times x would give me x squared. My outside, x times 3, gives me positive 3x. My inside, positive 5 times x is positive 5x. And my last, positive 5 times positive 3 is positive 15. And when I put these like terms together that are in the middle, the 3x and 5x gives me 8x. So I would have x squared plus 8x plus 15. So once again, here's going to be our steps. It's going to give us the zeros and say, okay, I want you to come from here to find the function that they came from. So I'm going to take them from the 0 to the factors, which is the x plus 3x, x plus 5, and then FOIL those factors together to get all the way back up to x squared plus 8x plus 15. So let's look at number 1. So it says to find the function of degree 3. When it tells you what the degree of the function is going to be, it's telling you what the highest exponent of the function is going to end up being. So if it's saying degree 3, that means you're going to end up with x to the 3rd as your highest exponent. So it wants us to find the function of degree 3 with real coefficients that has the given zeros. So it tells me the zeros are -3, 4, and -5. So remember, if these are the zeros, now we're going to take them back to the factors that they came from. So let's see, if -3 is the 0, that means it came from x plus 3, right? We're just changing that sign. Same here. If the 0 is 4, that means it came from x minus 4. If the 0 is -5, that means it came from x plus 5. Now, here's where it gets cumbersome and tedious and monotonous. The main thing you're going to want to do, because we're going to multiply these three factors together, which means we're going to FOIL these two. We're going to get a solution, and then we're going to distribute that solution to the x plus 5. So keeping your work organized is going to be very helpful on this section. So let's see. When I FOIL this, x times x gives me x squared. My outside, x times -4 gives me -4x. My inside, +3 times x is +3x. And then my last, +3 times -4 is -12. Now, I can put together those middle two terms, right? Since they're both x's. So I'll now have x squared. When I put these x's together, -4 plus 3 leaves me with -1x. Bring down my -12. So that's what I get when I multiply these two factors together. I've still got this one to go. So I'm just bringing it down. So now, here's what you got to do to multiply these two together. You've got to distribute all three of these terms to each one of those. So I'm going to try to color code it. This x squared will go to both of those first. So let's see, I've got x squared times x, which is x to the third. X squared times 5 is 5x squared. So it's kind of like you're done with that x squared now. Moving on to the next term in here, which is this -1x. So let's see, this -1x goes to both of those. So I've got -1x times +x. So negative times a positive is going to give me negative. X times x gives me x squared, or -1x squared. Then to the +5. So I've got -1x times +5, which gives me -5x. So now it's like I'm done with this one. Now all I have left to do is distribute that -12. So it's going to go to the x and the 5. Can't see it very good. So -12 times x gives me -12x. -12 times +5 is -60. And then the last step is to just clean it up. Put together your like terms. So let's see, no other x to the thirds. But I can put my x squareds together. I've got 5 minus 1, so that altogether I have 4x squareds. Put my x's together. I've got -5x and -12x. I can put those together, which gives me -17x. And then bring down that -60. So this is the function that if you graphed it in your graphing calculator, it's going to cross through the x-axis at those three numbers, at -3, +4, and -5. Now, when you're entering this, it's kind of weird how they have it set up to enter the answer. It's actually got almost the whole answer. The only thing that's missing is that number right there. And you'll see that if you have printed off your paperwork for today. So this right here, that positive 4, it's got everything else written out. It's just missing that 4 right there. Okay, but you can't get to that 4 unless you do all the work. Now, try to get a chair that's not so squeaky. Before we do number 2, earlier in the semester, we did some work where we were solving quadratic equations and things, and sometimes we ended up with an I in our answer. Okay, the I comes from the square root of -1. That's what equals I. Now, since we're going to be in this next problem has some I's in it. So that's why I want to kind of give a refresher. When we're multiplying I's together, sometimes you're going to end up with an I squared. So let's think about what that is equal to. Think about, so if I squared this side of my equation, that means I would have to square this one. So on the right, there's my I squared. I just want to know what that's equal to. Well, on the left, this squared just knocks out that square root. So all you're left with is that -1. So anytime you run into an I and it's squared, you're just going to turn it into -1. Because on number 2, it's just like number 1, but the zeros that it gives me that I'm going to work backwards from are 1, 3i, and -3i. So just like the last one, we're going to go backwards from our zeros to our factors. So let's see, if this is the 0, what factor did it come from? Would it come from x minus 1? These work just the same. If positive 3i is the 0, it came from x minus 3i. This one would have come from x plus 3i. Now, when you're multiplying these binomials together, you're looking for things that are going to help you out, because if not, you can get into a big mess, because what you like to see are 2 of the binomials that are what are called conjugates of each other. That means that everything's the same in the 2 binomials except for their sign in the middle. That's what's different about the 2 binomials. If you multiply binomials like that together, there's going to be some stuff that's going to cancel out and give you fewer terms to work with. I can multiply in any order that I want. I can pick the order, right? Because when you're multiplying, let's just say for the simplicity of it, if you're multiplying 2 numbers together, does it matter what order the numbers are in? For instance, if you multiplied 3 times 2, you're going to get the same exact thing you would get if you multiplied 2 times 3, right? You can do it in any order. The answer is still going to be 6. So what I'm going to use that rule for is to say, okay, I'm going to leave this one alone right now and multiply these together because they're conjugates of each other. Let's see what happens when we multiply those together. My first, x times x gives me x squared. My outer, x times positive 3i. It looks like we're getting into a mess. So positive 3, x times I is just xi. But look at your inner. Negative 3i times x is negative 3 xi. And when I use i's, I always put them on the end of the term. So you'll notice what's happening here. What's going to happen with those is they're just going to cancel each other out and get us out of having terms that look like this. And then the last part of FOIL, negative 3i times positive 3i is negative 9. And here's where we're going to run into the I squared. So like we said, those two terms are going to combine and cancel each other out. That is going to happen 100% of the time when you multiply conjugates together. That's why you like to do those first, to get rid of some stuff. Now, all I'm left with here is the x squared. Now, remember what I squared is equal to. We talked about it right before we did this problem. This really says -9 times -1, which turns this whole thing right here into a +9. So I don't even have any i's left to deal with. That's why you want to do these two first. So all I'm left with after those cancel, and that turned to +9, all I'm left with is x squared plus 9. Now I'll drop down my x minus 1 and FOIL what I have left here. So my first, x times x squared gives me x to the third. My outer, x times +9 gives me +9x. My inner, -1 times x gives me -1, not just x, sorry, -1 times x squared gives me -1x squared. And my last, -1 times +9 is -9. Now, when you enter this, again, it's just going to have the whole polynomial written out with missing numbers. So the first thing I need to do is switch these two terms, right? The x squared needs to come before the x. So I'll have x to the third, then my -1x squared, my +9x, and then my -9. So again, it's going to have that whole thing written out, except those numbers are going to be missing. Like even on this one right here, it's going to have the minus there for you, which means all that you're plugging in is that 1. And same all the way through. It's going to have the minus here for you. So all you're putting in that last spot is that 9 instead of -9. Okay? Number 3. All right, number 3, my zeros are square root of 7, -square root of 7, and 5. Okay, and another thing is anytime you have an I or a square root, there's always going to be both of them. There's going to be the positive and the negative of them. So when I turn them into their factors, there's always going to be conjugate pair factors also that you're going to want to multiply together first so things will cancel. Because if this is the 0, that means it came from x minus the square root of 7. This one came from x plus the square root of 7. And this one came from x minus 5. Now remember, it's up to us which two I want to multiply together first. So I'm looking for conjugates to make it easier on myself. And I noticed that these two are conjugates. So I'm going to want to multiply those together first. So here, my first, x times x gives me x squared. My outer combined with my inner should cancel each other out. That's what conjugates are going to do. So I have x times positive square root of 7, which is just positive x, square root of 7, and then look what my inner is, negative x, square root of 7. And then my last, negative times positive gives me negative. When I multiply the square root of 7 times the square root of 7, it gives me the square root of 49. Now, just like the last one, those middle two terms cancel. So all I'm left with here is the x squared minus the square root of 49. I can simplify that, right? The square root of 49 is just plain old 7. So that took care of multiplying these. Now I need to bring this one down, the x minus 5, and FOIL those. So my first, x squared times x gives me x to the third. My outer, x squared times negative 5 gives me negative 5x squared. My inner, negative 7 times x is negative 7x. And then my last, negative 7 times negative 5 gives me positive 35. And when I get down to the end, all my terms are in the right order, right? The exponents start at the top and go down. And nobody can even combine, right? Because none of these terms have the same exponent. So that's as far as you can go with that one. All right, number 4. My zeros are negative 1/2, 0, and 3. Negative 1/2, 0, and 3. All right, so let's turn these zeros into the factors that they came from. So this will be x plus 1/2. Now, if your 0 is a 0, that means the factor that it came from is just an x. Then this one's factor would be x minus 3. Now, remember, I can do the multiplication however I want, okay? I can do this times this, or I can do that times that, or I can multiply these together. It doesn't matter, as long as you end up doing all 3 of them. So the first thing I'm going to do, just because it doesn't have a fraction, is multiply those 2 together, and then just drop down my x plus 1/2. So if I distribute this x to here, x times x gives me x squared minus x times 3 is 3x. So that took care of those. Now I'll just drop down my x plus 1/2, because even though I tried to avoid it as long as I can, I'm eventually going to have to multiply with that fraction. So I'm going to FOIL here. X times x squared gives me x to the third. My outer, x times negative 3x gives me negative 3x squared. My inner, positive 1/2 times x squared is positive 1/2 x squared. And then my last, I have positive 1/2 times negative 3x. So I've got 1/2 times negative 3. You're multiplying fractions, think of that 3 is 3 over 1. And I guess it's an x. So if I go straight across on top and bottom, what do I have up top? 1 times negative 3x. And the bottom, 2 times 1 is 2. So when I multiply this positive 1/2 times negative 3x, it gives me negative 3 over 2x. Or negative 3x over 2, however you want to write it. Now, last thing, I got to finish and clean this up, right? These both in the middle here, they're both x squareds, which means I have to put those together. They're like terms. They both have the same exponent. So I'll bring down the x to the third. Now, remember, if you don't like adding and subtracting fractions, especially if they don't have the same denominator, you can do that in your calculator. What do I need to know? I need to know what -3 plus 1/2 is, right? I already know that I'm going to end there. They're going to be x squared. I just need to know how many. So -3 plus 1/2. Just type exactly that into your calculator. Then when you hit enter, it's going to give you a decimal. So you're just going to have to hit the math button and then hit enter twice to turn that decimal into its fraction. So -5/2 is what I'm left with. So when I put these together, it gave me -5/2. X squareds. And then just drop down the -3/2x. Okay, if you thought that was fun, just wait till number 5. There's no fraction, but it's a lot of work. All the ones that we've done so far have had 3 zeros that end up at degree 3, which means we're just multiplying 3 factors together. This one says, find the polynomial function of degree 6, which means we're going to multiply so much stuff together that we're going to end up with x to the 6th power right here. Okay, we actually have the same number of zeros, but this time their multiplicities are different. So let's look at number 5. So a polynomial with degree 6, -3 is a 0, but this time it tells me it has multiplicity of 3. 0 as a 0 of multiplicity 2. And 3 as a 0 of multiplicity 1. So I actually still only have 3 zeros, but look, they all have a different multiplicity. So your factors are still coming from the same spot, right? Your factors come straight from what the 0 is. If the 0 is -3, that means the factor that it comes from is x plus 3. But remember where the multiplicity number comes from. The multiplicity number is the exponent of that factor. This is what makes it long and drawn out. 0, which means its factor is just an x with multiplicity 2, so x squared. 3 is your 0, which means it comes from x minus 3, and luckily its multiplicity is 1. So here's what I have to multiply together, okay? Which means the first thing I'm going to do is this x plus 3 to the 3rd power. I'm going to do it over here and then put it back over there. So x plus 3 to the 3rd means x plus 3 times itself 3 times. When I FOIL this, my first x times x is x squared. X times 3 is 3x. My inner, another positive 3x. And then my last 3 times 3 is positive 9. So when I put my x's together in the middle, I really have 6x, right? I've got 3x and 3x. So that gives me 6 x's in the middle here. So now I've got x squared plus 6x plus 9, which came from multiplying these two. Now I have to drop down this last one, x plus 3 again. So now, just like earlier, I have to distribute this x squared to both of those. So let's see, x squared times x gives me x to the third. X squared times 3 gives me 3x squared. So I'm done with the x squared. Now I need to distribute this 6x to both of those. So 6x times x gives me 6x squared. 6x times 3 is 18x. And my last one now is I have to distribute that 9 to both things in the second parenthesis. So the 9 has to go to the x and the 3. So let's see what that gives me. 9 times x gives me 9x. And 9 times 3 is 27. So let's clean this up. No other thirds, so I'm just going to bring down my x to the third. But what about these squares? I can put my squares together. I actually have 3 here and 6 there, so that gives me 9 of them. And then I can put my x's together. I've got 18 and 9, so all together I have 27x. And bring down my plus 27. Okay, this is only part of it, right? So let's see what I have left here. That came from the x plus 3 cubed. So I'm going to put all that right here. So x to the third plus 9x squared plus 27x plus 27. Woo, that came from just this part right here. I'm just going to drop down the other two. I've still got an x squared and an x minus 3. Now remember, I can do it in whatever order I want. What I have left, I just have to make sure I do all 3 of them. Okay, just because I feel like I want a little break, I'm going to do these 2. So let's see, x squared times x gives me x to the third minus x squared times 3 is 3x squared. So now I've done those. I'm going to drop down all this over here. X cubed plus 9x squared plus 27x plus 27. This is the worst one. So here's what has to happen now. All of these terms have to distribute to each one of those. So this x to the third has to go to both of those. So let's see, I've got x to the third times x to the third, which gives me x to the 6th. Then I've got x to the third times negative 3x squared. Now remember, when you're multiplying and you both terms have x's on them, we're going to add those exponents together. So this x to the third times negative 3x squared gives me negative 3x to the 5th. Okay, so if you want to think about it, you can kind of say, okay, I'm done with the x to the third. Moving to this next term because it has to go to both of these. So I've got 9x squared going to both of those in the other parentheses. So 9x squared times x to the third gives me 9x to the 5th. Then I have 9x squared times negative 3x squared. 9 times negative 3 gives me negative 27. The x squareds, when I multiply those together, gives me x to the 4th. So now I'm done with the 9x squared. Then I'll move to this 27x. Move it to both of those. So let's see, 27x times x to the 3rd. When I add those exponents, I get 27x to the 4th. And then I have 27x times negative 3x squared. So 27 times negative 3 gives me negative 81. So you have negative 81x to the 3rd. So I'm done with the 27x. Now I'll move to the 27 and distribute it to both of those. 27 times x to the 3rd gives me 27x to the 3rd. Run out of room. I did the 27 times the x to the 3rd, gave me 27x to the 3rd, and I have 27 times negative 3x squared, which gives me 27 times negative 3 is negative 81x squared. Then all I have left to do is combine like terms. Okay, so I don't have any other x to the 6th. My x to the 5th I can put together. I've got negative 3 here and positive 9 there, which means together I have positive 6. X to the 5th. My x to the 4th. When I put those together, since that's negative 27 and that one's positive 27, they'll just cancel each other out. And then these are both x to the 3rd. So this one's kind of separated by that thing. So I have negative 81x to the 3rd and positive 27x to the 3rd. So negative 81 plus 27 gives me negative 54 x to the 3rd. I'm putting those together. And all I have left is the minus 81x squared. Okay, all right, that is the longest one that you're going to have. Okay, number 6. All right, this one isn't quite as bad because it's degree 4 instead of degree 6. It's still not great, but it's better than the last one. Okay, looking at number 6. Find a polynomial function of degree 4 with negative 1 as a 0 of multiplicity 3. And 0 as a 0 of multiplicity 2. I mean 1. Hang on. Negative 1 is a 0 of multiplicity 3. 0 is a 0 of multiplicity 1. All right, let's turn the zeros into their factors. So this one, since it's negative 1, will be x plus 1. Its multiplicity is 3, so that means to the 3rd power. This 0 is just a 0, which means its factor is an x, just an x. And since it's multiplicity 1, that's what makes this not too bad. I still have to do this x plus 1 to the 3rd. It's going to give me an answer here, but then I'm just dropping down this x, and I'm just going to have to distribute my x to those terms. Okay, so the hardest part of this one is just finding out, doing that long x plus 1, x plus 1, x plus 1. Okay, I'm going to do it again over here. Okay, so I'll have to FOIL my first two together, the x plus 1, x plus 1. So x times x gives me x squared. X times 1 is 1x. My inside, another 1 times x is 1x. And then my last 1 times 1 is 1. When you put these x's together in the middle, then you have two x's in the middle. So you've got x squared plus 2x plus 1. But what do you have to multiply this by? That other x plus 1. So let's distribute this. This x squared goes to both of these. X squared times x gives me x to the third. X squared times 1 is just 1x squared. So I'm done with the x squared. I'll move to the 2x and distribute it to both of these. 2x times x is 2x squared. 2x times 1 is 2x. So now I'm done with this 2x, and I'll just move to that positive 1. And it goes to both of those. So let's see what I have left here. 1 times x is 1x. And 1 times 1 is 1. So clean it up. No other x to the thirds. My squares. Put those together. I've got 1 here and 2 here. So I actually have 3x squareds. Right, I've also got 3 x's, right? Because I've got 2x here and 1x there. And then drop down that plus 1. So where does this go? That's what x plus 1 to the third is. X plus 1 to the third gave us all of that. So x plus 1 to the third gave me x to the third plus 3x squared plus 3x plus 1. Now, just like I said, this x is just going to drop down. So all I have left to do is distribute this x to all 4 of these terms. And what happens when you distribute an x to a term? It's just going to bump it up an x, right? So if I distribute this x to the third, I'm going to have x to the fourth. If I distribute this x to 3x squared, now I've got 3x to the third. If I distribute this x to this 3x, now I've got 3x to the second, and x times 1 is x. Okay, and then it gives us a little break on problems for numbers 7, 8, and 9. Now, remember when we had on problems 2 and 3, number 2 had that I in it, and it had both of them, right? And it made those conjugate pairs that we factored together, that we multiplied together. Anytime you have an I or a square root, you're going to have both of them. They're going to be a pair of them. So if you have I, then you also have negative I. Or if you have the square root of 2, then you also have negative square root of 2 as a 0. That's all it's asking you to do on these next few problems, is to find the missing 0. So on number 7, it says, suppose a polynomial of degree 4 has the given numbers of zeros, find the other 0. So the given ones are -4, the square root of 2, and 5/2. So what I'm doing, it says there's one missing 0. So I'm looking for anything that I know that would have a matching pair. Like I said, if there's a square root, then it's going to have the conjugate, the opposite sign of it. So if square root of 2 is a 0, so is negative square root of 2. So this is the missing 0, is negative square root of 2. Same thing on number 8. Says degree 4, and it gives me 2 zeros, -I and 3 minus the square root of 5. And tells me to find the other zeros. So if this one is a 0, since it's an I, so is the opposite of it. If this one, since it has a square root, that means it's conjugate. Its opposite sign in here is going to also be a 0. So it's going to be 3 plus the square root of 5 as the other one. And number 9 is like this also. The zeros that it gives me are 3 plus 5i and 1 plus the square root of 3. So let's see if this one, since it has an I, then I'm going to use the opposite of that sign to make my other 0. And same thing here. I'm just going to, since that's a square root, I'm just going to use the opposite sign as my other missing 0 that goes with that one. Okay, so we're going to use what we just learned on 7, 8, and 9 now to come up with functions where they give us some zeros, and then there's some obvious missing zeros because either there's an I or a square root. So we have to use those also, and then do all the FOIL, like on number 10. Says, find the function of lowest degree that has the given numbers of some of its zeros, -2i and 6. So the first thing I notice is that I have an I, which means that the other sign of it is also a 0. So I have 3 known zeros that I'm going to use to set up my factors and do the foiling. So let's see, what are these? Where do these come from? If this is the 0, it came from x plus 2i. This one came from x minus 2i. And this one would come from x minus 6. So now I'm going to multiply all these together. And remember, anytime I can do it in any order that I want. Anytime you see conjugates, you want to do those first so that some stuff will cancel for us. So since these are conjugates, let's FOIL here. So x times x gives me x squared. X times -2i gives me -2. And the xi just hook on each other. And then the inner should be the opposite of that, right? +2 xi. And then my last +2i times -2i gives me -4 I squared. Now remember, this looks complicated, but it's going to clean up a lot. First of all, the middle 2 terms just cancel. So here I'm just left with x squared. Now remember what I squared turns into. It turns into -1. So that really says -4 times -1 at the back right here, which makes it +4. So when I multiply these two together, it gave me x squared plus 4. Now I still have the x minus 6 that I need to FOIL. Distribute the x squared to both of these. X squared times x gives me x to the third. X squared times -6 gives me -6. X squared. My inner, +4 times x is +4x. And then my last +4 times -6 is -24. I would look to clean it up, but do any of these terms have the same exponent? And they don't. So that's as far as that one can go with those terms. None of them can combine. All right, number 11. Same thing, the zeros that it gives me are the square root of 3 and 4i. So since one's a square root and one's an I, both of them are going to have a pair, right? This one's pair would be -square root of 3. And this one's pair would be -4i. So I know of 4 zeros here. So let's turn them into factors. So this one will be x minus the square root of 3. This one will be x plus the square root of 3. This one will be x minus 4i. And this one will be x plus 4i. Yuck. So I do see that both of these are conjugates. So I'm going to multiply these together first. Then I'll multiply these two together because, again, these are conjugates also. So you're going to have a bunch of stuff canceled there. So I'm going to end up with 2 sets of parentheses that I will FOIL together in the end. Okay, so let's go with this first set. X times x gives me x squared. X times the square root of 3 gives me +x square root of 3. But look what the next one is. The inner is -x square root of 3. And then the last, negative square root of 3 times positive square root of 3. So a negative times a positive gives me negative. And then the square root of 9. So, like I said, this one right here, the middle two terms cancel. So all I'm left with is the x squared here minus, and then I can turn that square root into a plain number, right? Because what is the square root of 9? Or in other words, what times itself is 9? Plain old 3. So that took care of those two. Now I need to FOIL these two together, and it's going to end up with a parenthesis just like this one that I will FOIL together. So let's see, FOILing here, my first x times x squared. You know what? Since these are conjugates of each other, what's going to happen with this term and this term? They're gonna cancel each other out. So can't I theoretically jump from multiplying my first together to straight to my last terms together? I don't need to do the outer and the inner because they're just gonna cancel each other anyway. So because what would I have out here? I'd have +4 xi, and then in here I'd have -4 xi. They're just gonna cancel each other. So let's just go straight to our last. I've got negative 4i times positive 4i, which is negative 16i squared. But remember what I squared is. This really says negative 16 times negative 1. So all I'm left with here is the x squared, and then that turns to plus 16. So when I multiply these two together, I'm just left with x squared plus 16. So all I have left to do is multiply these two together by FOIL. So x squared times x squared gives me x to the 4th. X squared times positive 16 is positive 16 x squared. My inner, negative 3 x squared. And then my last, negative 3 times positive 16 gives me negative 48. So let's see, my x squareds can go together. So I'll just bring down that x to the 4th. Whoops. Putting together the x squared, I've got 16 minus 3, right? Because these are both x squareds. So that gives me positive 13x squared, and bring down the minus 48. Okay? All right, so that was number 11.